In economics and finance, risk aversion is the behavior of humans when exposed to uncertainty, to attempt to reduce that uncertainty. It is the reluctance of a person to accept a bargain with an uncertain payoff rather than another bargain with a more certain, but possibly lower, expected payoff. For example, a risk-averse investor might choose to put his or her money into a bank account with a low but guaranteed interest rate, rather than into a stock that may have high expected returns, but also involves a chance of losing value. Example: a person is given the choice between two scenarios, one with a guaranteed payoff and one without. In the guaranteed scenario, the person receives $50. In the uncertain scenario, a coin is flipped to decide whether the person receives $100 or nothing. The expected payoff for both scenarios is $50, meaning that an individual who was insensitive to risk would not care whether they took the guaranteed payment or the gamble. However, individuals may have different risk attitudes. A person is said to be risk-averse if he or she would accept a certain payment of less than $50, rather than taking the gamble and possibly receiving nothing. Risk-neutral if he or she is indifferent between the bet and a certain $50 payment. Risk-loving if he or she would accept the bet even when the guaranteed payment is more than $50. The average payoff of the gamble, known as its expected value, is $50. The dollar amount that the individual would accept instead of the bet is called the certainty equivalent, and the difference between the expected value and the certainty equivalent is called the risk premium. For risk-averse individuals, it becomes positive; for risk-neutral persons it is zero; and for risk-loving individuals their risk premium becomes negative. Utility of money. In expected utility theory, an agent has a utility function U where X represents the value that he might receive in money or goods. Time does not come into this calculation, so inflation does not appear, is defined only up to positive linear affine transformation. In other words, a constant offset could be added to the value of U for all X, or U could be multiplied by a positive constant factor, without affecting the conclusions. An agent possesses risk aversion if and only if the utility function is concave. For instance, U could be 0, U might be 10, U might be 5, and for comparison U might be 6. The expected utility of the above bet is, and if the person has the utility function with U equals 0, U equals 50, and U equals 100, then the expected utility of the bet equals 50, which is the same as the known utility of the amount 40. Hence the certainty equivalent is 40. The risk premium is equals $10, or in proportional terms or 25%. This risk premium means that the person would be willing to sacrifice as much as $10 in expected value in order to achieve perfect certainty about how much money will be received. In other words, the person would be indifferent between the bet and a guarantee of $40, and would prefer anything over $40 to the bet. In the case of a wealthier individual, the risk of losing $100 would be less significant, and for such small amounts his utility function would be likely to be almost linear. For instance, if U equals 0 and U equals 10, then U might be 4.0001 and U might be 5.0001. The utility function for perceived gains has two key properties: an upward slope, and concavity. The upward slope implies that the person feels that more is better. A larger amount received yields greater utility. And for risky bets, the person would prefer a bet which is first-order stochastically dominant over an alternative bet. The concavity of the utility function implies that the person is risk-averse. A sure amount would always be preferred over a risky bet having the same expected value. Moreover, for risky bets, the person would prefer a bet which is a mean-preserving contraction of an alternative bet. Measures of risk aversion under expected utility theory. Absolute risk aversion: the higher the curvature, the higher the risk aversion. However, since expected utility functions are not uniquely defined, a measure that stays constant with respect to these transformations is needed. One such measure is the Arrow-Pratt measure of absolute risk aversion, after the economists Kenneth Arrow and John W. Pratt, also known as the coefficient of absolute risk aversion, defined as the following expressions relate to this term. Exponential utility of the form is unique and exhibiting constant absolute risk aversion, is constant with respect to C. Hyperbolic absolute risk aversion is the most general class of utility functions that are usually used in practice. Kara and quadratic utility all exhibit hara and are often used because of their mathematical tractability. A utility function exhibits hara if its absolute risk aversion is a hyperbolic function, namely, the solution to this differential equation is wherein. Note that when this is kara as, and when this is CRRA as, C decreasing, increasing absolute risk aversion is present if is decreasing, increasing. Using the above definition of ARA, the following inequality holds for DARA, and this can hold only if. Therefore, DARA implies that the utility function is positively skewed, that is, analogously, IARA can be derived with the opposite directions of inequalities, which permits but does not require a negatively skewed utility function or coefficient of relative risk aversion is defined as. This measure has the advantage that it is still a valid measure of risk aversion, even if the utility function changes from risk-averse to risk-loving as C varies, i.e., utility is not strictly convex, concave over all C. A constant RA implies a decreasing RA, but the reverse is not always true. As a specific example of constant relative risk aversion, the utility function implies RA equals 1. In intertemporal choice problems, the elasticity of intertemporal substitution often cannot be disentangled from the coefficient of relative risk aversion. The isoelastic utility function exhibits constant relative risk aversion within the elasticity of intertemporal substitution. When using L'Hopital's rule shows that this simplifies to the case of log utility, U equals log C, and the income effect and substitution effect on saving exactly offset. A time-varying relative risk aversion can be considered. Implications of increasing, decreasing absolute and relative risk aversion. The most straightforward implications of increasing or decreasing absolute or relative risk aversion, and the ones that motivate a focus on these concepts, occur in the context of forming a portfolio with one risky asset and one risk-free asset. If the person experiences an increase in wealth, she will choose to increase the number of dollars of the risky asset held in the portfolio if absolute risk aversion is decreasing. Thus economists avoid using utility functions, such as the quadratic, which exhibit increasing absolute risk aversion, because they have an unrealistic behavioral implication. Similarly, if the person experiences an increase in wealth, she will choose to increase the fraction of the portfolio held in the risky asset if relative risk aversion is decreasing. Portfolio theory. In modern portfolio theory, risk aversion is measured as the additional marginal reward an investor requires to accept additional risk. In modern portfolio theory, risk is being measured as standard deviation of the return on investment, i.e., the square root of its variance. In advanced portfolio theory, different kinds of risk are taken into consideration. They are being measured as the nth radical of the nth central moment. The symbol used for risk aversion is A or UN. Limitations of expected utility. Treatment of risk aversion. The notion of using expected utility theory to analyze risk aversion has come under criticism from behavioral economics. Matthew Rabin has showed that a risk-averse expected utility maximizing individual who, from any initial wealth level, turns down gambles where she loses $100 or gains $110, each with 50% probability, will turn down 50 to 50 bets of losing $1,000 or gaining any sum of money. Rabin criticizes this implication of expected utility theory on grounds of implausibility. One solution to the problem observed by Rabin is that proposed by prospect theory and cumulative prospect theory, where outcomes are considered relative to a reference point, rather than to consider only the final wealth. Risk aversion in the brain. Attitudes towards risk have attracted the interest of the field of neuroeconomics and behavioral economics. A 2009 study by Christopoulos et al. Suggested that the activity of a specific brain area correlates with risk aversion, with more risk-averse participants also having higher responses to safer options. This result coincides with other studies that show that neuromodulation of the same area results in participants making more or less risk-averse choices, depending on whether the modulation increases or decreases the activity of the target area. Public understanding and risk in social activities. In the real world, many government agencies, e.g., Health and Safety Executive, are fundamentally risk-averse in their mandate. This often means that they demand that risks be minimized, even at the cost of losing the utility of the risky activity. It is important to consider the opportunity cost when mitigating a risk, the cost of not taking the risky action. Writing laws focused on the risk without the balance of the utility may misrepresent society's goals. The public understanding of risk, which influences political decisions, is an area which has recently been recognized as deserving focus. David Spiegelhalter is the Winton Professor of the Public Understanding of Risk at Cambridge University, a role he describes as outreach. A vaccine to protect children against the 3 common diseases measles, mumps and rubella was developed and recommended for all children in several countries, including the UK. However, a controversy arose around fraudulent allegations that it caused autism. This alleged causal link was thoroughly disproved, and the doctor who made the claims was expelled from the General Medical Council. Even years after the claims were disproved, some parents wanted to avert the risk of causing autism in their own children. They chose to spend significant amounts of their own money on alternatives from private doctors. These alternatives carried their own risks which were not balanced fairly, most often that the children were not properly immunized against the more common diseases of measles, mumps and rubella. Mobile phones may carry some small health risk. While most people would accept that unproven risk to gain the benefit of improved communication, others remain so risk-averse that they do not. Risk aversion theory can be applied to many aspects of life and its challenges, for example, bribery and corruption, whether the risk of being implicated or caught outweighs the potential personal or professional rewards. Drugs, whether the risk of having a bad trip outweighs the benefits of possible transformative one, whether the risk of defying social bans is worth the experience of alteration. C. Harm reduction. Sex, judgment, whether an experience that goes against social convention, ethical mores or common health prescriptions is worth the risk. Extreme sports, weighing the risk of physical injury or death against the adrenaline rush and bragging rights. Play by children in playgrounds or beyond the reach of their parents. A recent experimental study with student subject playing the game of the TV show Deal or No Deal finds that people are more risk-averse in the limelight than in the anonymity of a typical behavioral laboratory. In the limelight treatments, subjects made their choices in a simulated game show environment, which included a live audience, a game show host, and video cameras. In line with this, studies on investor behavior find that investors trade more and more speculatively after switching from phone-based to online trading, and that investors tend to keep their core investments with traditional brokers and use a small fraction of their wealth to speculate online.